Okay, so let's see the program. Okay, so first you have to import few modules. So these are your NumPy, Matplotlib, and sklearn. Now there is one more module, that is your iter tools. So this is for iteration purpose. Okay. Next part is to load data from input file. So we have used data clustering.txt file, which we have used in our previous algorithm, that was your k-means algorithm. So we are using again load.txt function to load data from that file. Now this file is containing data in comma separated value, so that's why we have used that delimiter. Okay, now let's see this file. So I think this is your file. So it's containing data, two numbers separated by a comma. Again two number separated by a comma. So it is representing your two-dimensional data, that is your 2D data. So we have loaded data from that file. Next, we are estimating our bandwidth. Now why we are estimating our bandwidth? So let's see this. Okay, just remove it. Bandwidth is a parameter of the underlying kernel density estimation process used in Meanshift algorithm. So this is your parameter for your density estimation. Now your bandwidth affects the overall convergence rate of the algorithm and the number of clusters. So that's why we have used this parameter. If your bandwidth is small, then it will result in too many clusters, and if its value is large, then it will merge your distant clusters, that is less number of clusters. Next is your quantile parameter. So what does it represent? The quantile parameter impacts how the bandwidth is estimated. A higher value for quantile will increase the estimated bandwidth, and that will result in a less number of clusters. So that's why we are estimating your bandwidth, and we have used here quantile parameter. Okay. Next we are using, that is your important task here, Meanshift. Now what is that? Meanshift you know very well, that is your centroid based algorithm which works by updating candidates for centroids to be the mean of the points within a given region. So we have discussed this. Now why we are using here for clustering purpose? So it will cluster data. Now here we are passing few parameters. So first is your bandwidth, that is you have estimated, and you know why we have estimated this parameter. Next is your binary seeding. Now what does it represent? There is one more parameter, that is your seeds. So seeds is used to initialize kernel location, and if it is not set, here is it is not set, then these will be calculated by clustering.get binary seeds with bandwidth. So we have not set here our seeds parameter, so that will happen. What is binary seeding? So setting this option to true will speed up the algorithm because fewer seeds will be initialized. So what does it represent? It true, initial kernel locations are not location of all points, but rather the location of the discretized version of points. So that's why we have set it true, and we have not set our seeds parameter. Next, if your bandwidth is not given, then your bandwidth will estimate it using sklearn.cluster.estimate bandwidth module. Next part is your extracting the centers of clusters. So you will use your Meanshift model, that is your this Meanshift model which is returned by Meanshift, this function, and then dot cluster centers. So this will extract your centers of the clusters. So cluster centers is representing your center of clusters. Next, we are estimating the number of clusters, so we will use labels of Meanshift model. Now we will calculate the length of the labels, and this will be your number of clusters and input data. Next, we are plotting our points and cluster centers, so we will use here markers O star X V S. Since we have 5 clusters, so we are using 5 markers for representing our data. So we are using a for loop in which we are using the scatter function, and X is representing your data which you have loaded from our dataset file, and you are using marker. So each time in loop one marker will come and it will plot our data. Next we are also plotting here cluster center of that cluster. So we will using cluster centers I. So cluster centers is your array which we have calculated earlier, and that is your cluster centers, and in each loop we are plotting our one cluster center of that clusters. So we are using your marker O for that cluster center, and edge color will be black and size is your 15. Next we are giving our title clusters to the plot, and then we are using show function to display our plot. So that was your program. Let's run it. First you need a console, so we are opening our IPython console. So it is connecting to kernel. Okay, it's restarting. Okay, let's see this. So these are your centers of clusters, that is position of clusters, and number of clusters are your 5 here, and then this is your plot for the cluster. So there are 5 clusters and these are your center of clusters which you have plotted using your for loop. And we have used here 5 different markers, that is X, this triangle, O star, and the that was your plot for the clusters, and we have plotted here 5 clusters. So that's it. That was your clustering method, and we have used your Meanshift algorithm. So just follow this method and try to create clusters using that method.